now let's determine both these limits. And the first one we have limit as x approaches 3 of 1 over x minus 3. So I'm just going to quickly draw this function actually. We have an asymptote here at x equals 3. And why is that? Because, well, if we were to plug in 3 for x, we would get 0 down below. So that gives us an asymptote. And the rest of the function is just going to look like this. Let me see if I can do a quick yet good job at drawing this function. I hope I can. And what we're going to be doing, of course, is then we're going to visualize the answer to the limit. A graphical approach is not a bad idea, especially right now because I want everyone to visualize exactly what I'm doing and why the limit's going to be what it is. And there we go. That's not that bad a job, right? So yes, these lines represent 1 over x minus 3. So we want to determine, of course, the limit as x approaches 3. Here's the funny thing though. We need to determine the limit as x approaches 3 from the right of 1 over x minus 3, and that would be just positive infinity. If you have watched our intro video, that should make sense, because as we approach 3 from the right, this is x equals 3, so as we're approaching 3, this is just skyrocketing. The function is just going straight up. So that's just going to be infinity, positive infinity. What if we're looking for the limit as x approaches 3 from the left? Well, here's a function, and as we approach 3 from the left, it just takes a free fall. And the limit will actually be negative infinity. And do you recall what happens when the limit as x approaches 3 from the right? The limit as x approaches 3 from the left will indicate, when we're trying to determine the limit as x approaches 3 for this function, well, it just won't exist, since the limits coming from the right and the left are just different. So this guy, this limit, does not exist.